Next up, we have Mark Niemann-Ross on using R to control a Raspberry Pi with audience participation.
Don't lose it. Don't plug it in. Good. Okay. Oh, here we are. Oh, great. I'm Mark. You don't care. Let's see. Wait a minute. I know this. How does this work? Go, go, go. Go, 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 go.
Oh, I can.
No, I got it. I can do this. Thank you.
There's a light bulb.
Don't. Okay. Who's playing bingo? Okay, good. I did that this morning. All right. So going to talk about how to run a Raspberry Pi with R. And the important thing to understand about a Raspberry Pi is it's very, very much a physical device. It's intended. It's intended as part of something called Internet of Things. You'll also hear me talk about edge computing. And there's a lot of things we got to talk about. First, we're going to talk about the physical side of things. So I've invited some actual physical people to help me show what's off. Oh, I forgot to mention, starting over there, 1, 2, 3, 4. Okay. All right. Volunteer number 1, would you take a half a step forward? Good. Now, what she is holding is a Raspberry Pi laptop that I have built. Can you all see inside of it? Yeah, okay, right. You probably can't because it's in the back of the room. But what you're seeing is there's a Raspberry Pi, there's a monitor, and there is a breadboard. So I can run around and plug stuff into it. Okay, thank you, volunteer number 1. You can step back. Volunteer number 2, carefully, over your head, show them what you have in your hand. That is a Raspberry Pi 4. Okay. Honestly, that is a Linux computer. It runs on 5 volts. Yeah, that's what I put. Consumes about 3 to 6 watts. It's almost nothing. Okay, step back. Good job. Well done. Volunteer number 3, step forward. That, yes, don't lose it. That's also a Raspberry Pi. This is a Raspberry Pi 0W. It's a full-blown Linux computer. Isn't that cool? It runs on 5 volts and it's about the size of a pack of gum, and it uses about the same amount of electricity. So it's great for embedded devices that have to run, say, on solar panels, out in the woods, or like in a Montana oil field, something like that. Okay, now volunteers 1, 2, and 3, take a half a step forward. The commonality about all of these 3 things, and they're going to point to this now for you, are the set of pins. There are 40 pins on each board. Yep, they're the spiky things. Yeah, okay, good. Those pins are what's called a GPIO, general purpose IO. The pins have a bunch of functions. One of them is to supply ground. One of them is to supply 5 volts. One of them is to supply or to read a 3-volt sensor. And then the 4th of them is like, there's other things such as SPI, I2C, 1 wire. Those are electronics interface protocols. And I'm not going to talk about them right now. The important takeaway is that each of these devices is able to control the world around it and read information from it. Okay, volunteers 1, 2, and 3, thank you. You can put your props in the suitcase to your right and return to your seats. Now, volunteer number 4 is wondering, what did I do wrong? He has done that. Well done. You're doing great. Okay, I asked him not to plug this in. What this device is it's a light bulb. You've all, I mean, it's bigger than an LED, but it's a light bulb. On the side of it, which he's going to point to right now, is a small white box. That is called an SCR. It's a silicon controlled relay. On the top of that, it says it will control anywhere up to 340 volts. Yes, thank you. That's exactly right. For those of you who have played around in the kitchen, you'll know that, or in your electric car, or your dryer, that takes 220 volts. This little thing can control things like refrigerators, kitchen appliances like blenders, or the thing that really makes me excited, a standard household oven. Now, unfortunately, my family has forbid me from playing with household appliances, so I have to stay out. But there's a whole bunch of stuff you can plug into in a 220-volt outlet, and you can control it with a Raspberry Pi. So imagine a Raspberry Pi 0W connected to the two red wires, the red wire and green wire. Yep, that's where you, good. Okay, so you connect it up to that, and hey presto, you can now control full-scale devices. Thank you. All right, round of applause for our volunteers. Okay. All right, that's the physical, well done, by the way. Yeah, okay. That's the physical part of what we're working with. So that's a Raspberry Pi. And part of it is I'm starting to imply, why in the world would you want to do this in the first place? What is the big deal about installing R on a Raspberry Pi? Well, okay, before I get to that any further, I want to give you the very boring part, which is how to install R on a Raspberry Pi. Ta-da. That's it. It's for those of you who do Linux, this is standard app.get, app-get. Raspberry Pi runs a version of Linux Debian called Raspbian. Forget it. It's just standard Linux. There's lots of different installations. You can spend lots of time worrying about it. Installing R on a Raspberry Pi is one of the more boring things you can do in your life, honestly. So I had to spice up the speech. Now, what you're looking at here, this is where it gets tricky. Okay, installing R on a Raspberry Pi is simplicity itself. Using R on a Raspberry Pi, well, this is where we get a little bouncy. Okay. First thing you're going to have to do, what we're looking at is the desktop for Raspbian running on a Raspberry Pi. Looks very much like, Windows, like Macintosh. It's a standard windowing environment. The problem is that when R is installed on a Raspberry Pi, it goes into the graphics menu. Don't know, didn't ask. Didn't tell me. So the first thing you're gonna have to do is fix the app menu. Rather than show you how to do this live, I will encourage you to download the slides and step through this as an experiment on your own time. You'll also have to fix the icon because it comes up with an unknown icon. Yes, you really do want the R icon because that's who we are. And this tells you how to do that. So, okay, now, then of course, you'll want to install a GUI, graphic user interface, for those of you who don't like TLAs or three-letter acronyms. So it's important that you, well, here's the problem, okay? There's a bunch of graphic user interfaces for R. One of them, is R GUI. One of them is R commit, all of those things. One of those is Posit R Studio. What are we calling it now? Yeah, okay. And then there's R in the cloud, right? You can run R in the cloud. Everything's great. The problem is, hi, Karen. Kim. Hi, Kim. Everyone wave hi to Kim. Hi, Kim. Okay, the problem with R in the cloud, there's a couple of problems. First of all, let's talk about Posit Studio, R Studio, which doesn't have a version that runs on the Raspberry Pi. Okay, problem number two, if you run R in the cloud, you cannot access the local device store on the machine itself. And so you cannot control the GPIO from R in the cloud. You need a GUI that runs on the board. So the only thing that really is out there is something called Genie. It's called GEANY. It comes with a standard Raspberry Pi Raspbian installation. It's a cute little environment. You can configure it to run a lot of different languages. Again, I am not going to step through the process of configuring Genie to run on a Raspberry Pi with R. I'll leave that to your own devices. But right now, I will save you the time and effort of trying to find a GUI that runs on the Raspberry Pi and can control R. Okay, until somebody from pause it, takes notes and writes to their friends and says, gosh, I just saw this awesome lecture. We really ought to look at the ARM64. Okay. All right, fine. Now, what does this look like? Oh, look, run R. Can you all read that? Okay. How many of you used Cowsay? 5 minutes. Really? I only have 5 minutes left. Oh, crap. Okay, fine. Well, we got the important parts covered. Okay, so Cowsay, who cares what this is? This is R, ta-da, and you can run it on a Raspberry Pi. Isn't that fun? What's more important is controlling all of the pins on a Raspberry Pi. This is where you get into controlling things like ovens. I'm sorry, not ovens, because I'm not allowed in the kitchen with this stuff. Other things. What you'll need is a GPIO access library. Again, here's a slide. You use sudo apt-get install lib gpiod. It's all on the slide. There are five different libraries that that you can pull in to control input and output on a Raspberry Pi. Before you do this, I really highly recommend that you take a look at the slide set and that you play around with some of the stuff. It's the deep end of the pool, folks. Sorry. Okay. But look, here's a Raspberry Pi. Here's a breadboard. Here's a button. And the two little lines, red line, yellow line, indicates how to hook this up. And if I had 15 more minutes, no, I would hook up a button and show you how it works. But this is the code that it would run to be able to read a button. It's real. I mean, if it looks like R, honestly, it's just boring R. Okay, with a library thrown in there. Oh, by the way, who else is playing bingo? You have the GitHub question? Okay, great, there it is. Okay, now this gets a little bit more complex. Now we're going to control the GPI, and this means when you push the button, the light goes on. How am I doing? Again, this is more than I can do in the next 2 minutes. But believe me, trust me, you plug everything in, you push the button. Be careful, don't mix up the ground and the power because you'll let out the magic white smoke. You push the button and then everything works. Isn't that great? Here's the code to do that, again, on GitHub. But the takeaway here is this is just pretty much standard R. So for example, now why would you want to do this? Let's see, I think I got everything covered. Oh, here's a good thing. Okay, $1 million question. Why would you want to use Python with R? Anybody? I'll give you the answer. Because a lot of device drivers are written in Python or C. So that if you need, rather than writing up, I've got 2 minutes. Oh, plenty of time. Okay. Did you know that's what she's doing? She's telling people how much time they have. She's not like, it's not like jokes, or your zipper's undone or something. Okay, so where was I? Oh yeah, RCPP or reticulate. Because again, these device drivers are written in C and in Python. And rather than reinvent the wheel, you might as well just go out and use a device driver that somebody else has sweated and pained and agonied over, and then just bring it into R. Isn't that magic? And then what you can do is use the code that you know, R, to develop the data forms that you know, data frames, and pull in data off of the GPIO and send it out. Okay, let me give you, okay, so I'm going to give you, for instance, one person that I worked with, and this is true, this is up in Wyoming. They had oil derricks, the things, it's the birds, right? They do this thing all day long. And they have pumps. And if the pumps go out, it means big money. Pumps are bad, but these things are located out in the middle of nowhere. So you really want to maintain records on how things like the temperature of the bearings. So they set up a device that would monitor the temperature of the bearing. It took a reading every millisecond. Don't know why. And then used satellites to beam the data back up. It flooded the network because all of these data readings, every millisecond, what's the temperature? I also wanted to know what the ambient temperature was. So, oh, sorry. Okay, good, quick. Okay, so what they did was they set up a Raspberry Pi to read the sensor, and the Raspberry Pi just said, okay, look, we really only need data every minute. And so it would generate a summary of the data. It would take and sample the ambient temperature, build this into a nice little package and up over the network. I hear you. So, okay, now, could you do that in Python? Yeah, sure. Would you rather do it in R? Well, you're in our conference, so that's more of an answer. Okay, I'm out of time. I'm out of things to say. I'm not even allowed to ask questions, right? We'll do questions later. Okay. Next.